Well, let's take a look at implementing the higher-lower pricing game in LabVIEW. The game objective is to guess the correct price before the clock runs out. That is, we want to do it as quickly as possible. We know the range, or the lower and upper limits of the price, and then we make guesses based on feedback. The feedback says actual price is higher than our guess, or the actual price is lower than our guess. To keep things simple, let's use a range of 0 to 255. 255 would be the maximum value for the unsigned 8-bit integer data type. Now with this information in hand, let's start forming some register transfer statements. Now much of this revolves around our current guess. Guess would be contained inside a register. Now sometimes guess needs to be filled with our initial guess, and 127 is the midpoint between 0 and 255. That's where we're going to get started. Now later on, we might need to say, well, let's make our guess higher. So we can add an offset to guess. And we'll add this offset anytime we're told that the actual price is higher. Similarly, we sometimes need to subtract that offset, and we do so when we're told that the price is lower. Now at some point, hopefully, we actually match the actual price, and when this happens, I want to keep the guess simply parked at its present value, and we'll do that when we're told that we've won the game. Now we have 4 different register transfer statements, so we need to assign some conditions here. Let's imagine a signal called new game, and when this one is active, that resets our guess to the midpoint value. When it's inactive, then we can consider the other statements. Now how do we know whether or not to do the plus offset or minus offset? Well, we could say that we could imagine a signal called higher, that when that condition is true, we would pick the positive offset. I think I'm going to backtrack here just a little bit and realize that anytime that our guess in fact equals the price, or is identically equal to the price, that's what that notation means, that we know we've won the game and we should stay parked at that value. That's actually a higher priority signal or higher priority condition to work with, so I'll worry about that one first. All right, so we'll say that if guess is not equal to the price, then we need to do something else. All right, now we can make our decision about should it be adding or subtracting the offset. Well, anytime that we see that the actual price is greater than our guess, that means we should add the offset. So for anything else, we would be taking the condition price is less than the guess. All right, let's think about the actual way we modify the guess. This is the offset. Offset is going to first be 1/4 of our range. We could think of it as half of the midpoint value. So we at the beginning of the games initialize that to 64. And then the notion here is that we make progressively smaller offsets, and that gets us closer and closer to the actual value. I'll use the technique of shifting right by 1 place, which is equivalent to dividing by 2. So this is the technique for making offset get a little bit smaller each guess. All right. These conditions might seem unusually complex, but actually I think when you see the LabVIEW implementation, you'll see that it's really not too bad. All right, here's the major players here in terms of actual price, the new game signal, the guess register, and the offset register. Here's the operation for shifting. I'll show you where that's located. That's part of data manipulation, and it's located right here. The logical shift node can actually do either a right shift or a left shift, and the negative one is indicating a right shift by 1 place. Well, let's take a look at this in operation. I'm considering the front panel right now. Let's go ahead and set a new game with a price of 75. So you see our initial midpoint guess. Here's the offset ready to go. There's the actual price. Let's go ahead and let this thing run. So you can watch the behavior of the guesses. That's our feedback indicating the higher, lower. Hey, we've been able to match the actual price with our guess. All right, let's try one that's kind of tricky for our algorithm. I'm going to set the price at just one above our midpoint guess. This is pretty much the worst case scenario as far as the contestant on the game show trying to apply this algorithm. I'll set the loop time just a little bit quicker so we can see the results unfold. And in a similar way, 126 is also kind of a worst case situation. In this case, we make our initial guess and then we keep told higher and higher until finally we win the game.